Hello students and welcome to your physics 10 lesson. Today we're still looking at kinematics. We're looking at questions involving equations of motion. So before we get into the lesson, I would just like you to remember these 4 equations we looked at in the previous lesson. We looked at each of them and how they are derived. So in this lesson we'll be basically looking at how we can apply these equations into real questions. So here's our first question. Calculate the average speed of an athlete who runs 1,500 meters in 4 minutes. So what we do is we get our formula for average speed, which is equal to total distance over total time. Then we organize our data. We've been given our total distance, which the athlete covered, which is 1,500 meters. And we've also been given the total time it took for this distance to be covered. It's given in minutes, so we need to convert it to seconds. And so to do that, we'll be simply multiplying 60 by 4 and we'll get 240 seconds. So average speed will be equal to 1,500 divided by 240. So if we punch this into a calculator, we can find the average speed, which will be equal to 6.25 meter per second. So this simply means the athlete was moving around the speed of 6.25 meter per second throughout the journey. You might be asking yourself, well, why didn't we use the other formula for average speed, which was initial velocity plus final velocity divided by 2? Well, we can't use it because in this question we haven't been given our initial velocity and final velocity. You will see how we know which formula to use in these other examples we'll be looking at. So we come to example 2. So a motorcyclist traveling at 12 meter per second decelerates at 3 meter per second squared. How far does he travel before coming to rest? Before we start anything in such a question, which really involves equations of motion, we need to collect our data. The first thing we should know is that we've been given our initial velocity. If you can remember, I said the initial velocity is the velocity at the start. Basically, we won't look at the velocity at the start of this journey of the motorcyclist, but initial velocity is just the velocity the body was traveling at before we were given the question, or when we were given the question. So this velocity is 12 meter per second. As you can see, it's the velocity that we've been told the cyclist was moving at. So it's the initial velocity he was moving at. Now, what is our final velocity? Well, our final velocity is just the velocity at the end of this journey. If you look, we've been asked to find how far it travels before coming to rest. So this statement, coming to rest, tells us that this body or the motion will come to 0 speed. Hence, our final velocity will be 0. You should also note that we've been given acceleration minus 3 meter per second squared. Why is it minus? Well, whenever we've been told about deceleration, it simply means negative acceleration. So this is why our acceleration is a negative number. You should recall that acceleration is a vector quantity, so it can bear positive and negative numbers. And we should not forget that we're required to find s, which is the distance. So to find this, we'll go through our equations of motion. The first one is v is equal to u plus at, s is equal to u plus v multiplied by t divided by 2. The third is s is equal to ut plus at squared divided by 2. Then our last is v squared is equal to u squared plus 2as. So this is just to get you a clear picture of how we get to know which equation we're going to use. To know which equation we're going to use, we should look into our data and see if the equation that we have can satisfy us to find S. So in the first one, as you can see, we don't even have S, so it cannot help us to find distance. In the second one, we have S in it, but if you can see, there's also T for time, and hence we have got two unknowns, S and T, so it cannot be useful for us to find distance. This also applies to the third equation of motion. We also have time in it, and so we can't use it to find distance. The equation of motion we would use is the fourth one. V squared is equal to U squared plus 2AS. Why? Because S is the only unknown thing in the equation. So what we'll do is we'll just replace our values or our data to its respective place. So for V here, we'll be replacing 0. For U, we'll be replacing 12. For A, we'll be replacing minus 3. So it will be 0 squared is equal to 12 squared plus 2 minus 3 and our S. This will give us 0 is equal to 144 plus minus 6S. So 12 multiplied by 12 is 144. These are some numbers you should know in your head and be at your fingertips here. So we'll have then 0 is equal to 144 minus 6S. You know this rule, when we've got positive and negative, we take the negative here. Then we take this minus 6S over to the left side of the equal sign, and we'll have 6S is equal to 144. But you can simplify this further by just dividing both sides by 6, and hence we'll have 6 and this 6 cancelling out, leaving us with S. So S is equal to 144 divided by 6, and S will then give us 24 meters. So this is how we can find distance using our equation of motion. Now let's look at example 3. In example 3, we are told a car is traveling at 30 meters per second and accelerates at 2 meters per second squared for 5 seconds. Now we're asked to find the distance traveled and the final velocity. So like we did, we'll get our data. We've been given our initial velocity, which is 30 meters per second. We've also been given our acceleration, which is 2 meters per second squared. And we've also been given our time. Note that we haven't been given the final velocity, as nothing including the body going to rest is put in the question. So our knowns are time S and final velocity V. So now in A, we've been asked to find the distance traveled. How do we do this? We'll use our third equation, which involves initial velocity, acceleration, and time. Then we replace our values. So we put 30 where there's initial velocity, 5 where there's time, yeah, just like that. Then what I want you to note is that under time here, we do not include A. So we do not say 2 multiplied by 5, then we square our answer. No. We will square our time here. So 5 squared like that. Hence, S will be equal to 150 plus 2 multiplied by 25 divided by 2. This 2 and this 2 will cancel out, and so we'll have S equal to 150 plus 25. So our distance is equal to 175 meters. Now, how do we find our final velocity? So to find our final velocity, we can use any of the 4 equations. But let's check our data if that is possible. Our data only makes it possible for us to find our final velocity using our first formula, which is V is equal to U plus AT. So our V is what is unknown, so we replace U with its value, which is 30, A with 2, and T with 5. So V will be equal to 30 plus 2 multiplied by 5. So V is equal to 30 plus 10. Hence, V is equal to 40 meter per second. That's how we use our formulas in equations involving equations of motion. Thanks for watching today's video and look out for our next video.